Let's take an example. We're going to let set A equal Monday, Wednesday, Friday, Saturday, and set B is going to be Tuesday, Friday, Saturday, Sunday. All right, so then the universal set is going to be all the days of the week. So we're just going to kind of fill in here. So all days of the week. All right, so let's go find A union B. So union is going to take and merge all of these together. So A itself has a Monday, but then B has Tuesday, so we're going to bring it in. Set A has Wednesday. Does anybody have Thursday? No, so we don't have Thursday in A or B, so it's not there. But set A also has Friday and Saturday, and set B has Sunday. So taking and merging those sets together, we have Monday, Tuesday, Wednesday, Friday, Saturday, Sunday. Now, when we look for the intersection here, this is the intersection. That means I'm looking for where they overlap, what they both have in common. So if we look at sets A and B, what days of the week are in both sets? They both have Friday and they both have Saturday. Looking at a complement, remember the complement is what's not in A. So the universal set is we're looking at all 7 days of the week. A already has Monday, Wednesday, Friday, Saturday. What's not in set A? Well, Tuesday is not in set A. Neither is Thursday in set A, and neither is Sunday in set A. And so the complement is what's not in A. A doesn't have Tuesday, Thursday, or Sunday from the days of the week. B complement next would be what's not in B. So days of the week, B does not have Monday. It does have Tuesday. It does not have Wednesday. Set B does not have Thursday, but it does have all the other days. Set B has Friday and Saturday and Sunday. All right, next example, we're going to look at A complement intersected with B. So remember, this is an intersection. So what I'm going to do is I need to go find my A set, or my A complement. So this is what I'm looking at right here. I'm looking at my A complement, and I'm looking at my B set, and I want to know what is in both of them. What's in both A complement and B. And you'll notice that both of them have Tuesday, and then they also both have Sunday. So we can do examples of sets, not necessarily even with numbers. We just did some sets using days of the weeks. All right, next we're going to go do some Venn diagrams. I'm going to introduce them. A Venn diagram represents the relationship between sets. We do it kind of with a picture image. We're going to have a universal set, which is the outside rectangle, and then inside we're going to have sets A and B to work with. All right. So here we are looking for a intersection B. So A intersected with B. What do they both have in common? So if we're looking for the intersection, what region is in both A and in B? And that would be right here, kind of in the middle in this overlap area. All right, so that is their intersection. On the next one, we want to do a union B. So union means we're looking for A or B. Anything in A or B makes it in. So because I'm unioning, that means I'm going to pick up all of A, and I'm going to come back and shade that, but I'm unioning it with all of B. And therefore, the union ends up being the overlap, what they both all have. So there's the union, all of it shaded. So you'll notice typically the intersections are very small. Unions tend to be a lot larger because a union's going to merge everything together. To find A intersected with B complement, we're going to first shade our A. Just getting a quick shading on it there. And then we need to go find our B complement. Now remember, B complement is everything outside of B. So I'm just going to come in, kind of use a different color here, and I'm going to go mark everything outside of B. All right, now as we're looking for this, remember this is an intersection, so we want where do they both overlap? Well, they're both overlapping here in this region right there. So that would be our answer field. That would be the part that is both in A and in B complement. All right, looking at our next one, we are looking for A complement union B complement. Now a union merges it all together. So I'm going to go highlight A complement, and A complement is everything outside A. So just kind of doing a little quick sketching here for everything outside of A. And then we're going to take and go find B complement. B complement is everything outside of B. So I'm just going to do a quick kind of sketch here outside of B. I'm just going to pick up everything outside of B. And therefore, the union ends up being pretty much all of the shaded regions except for the overlap between A and B. All right, looking at our next example, this one is unique because it asks us to find A union B and then the complement. So in other words, what's not in A nor in B. So first, let's go find what A complement is, or what A is. And so I'm going to shade A, and then we're unioning it with B. So I'm going to shade my B. And we're looking for the complement. We are looking for what is not A union B. So what is not A union B? So that's all of the area outside of it. And therefore my highlight would be the answer. All right, next up, we're asked to draw disjoint sets. Remember, disjoints share no intersection, nothing in common. So that would be one set and another set. Those are both examples of disjoint sets. On our next example, we're going to look at a classroom of children. Some have a toy car, some have a jump rope, and some have both. So we're dealing with two types or two categories. We have some with toy cars, and we have some with jump ropes. Always start with the intersection. How many have both? 4 have both a toy car and a jump rope, so I'm going to put my 4 there. Now within those 4, we have 15 with the toy car. That's our toy car. But we have to remember that that 15 includes the 4 already listed. So if there's 15 in the toy car circle, we already have 4 in the intersection. So that's going to leave 11 to put in the outside toy car only section. All right. In the jump rope circle, we have 9, but we do already have 4 listed in the jump circle. So we're going to pull out those 4. That leaves 5 that are going to be jump only. So the question, how many are here? We're not given any information as far as if there were any that didn't have them. So we're going to assume that all of them are in those circles. We add 11, 4, 5. That gives us 20. So there would have been 20 children in this classroom.